Okay, here we go. Listen, welcome and thank you for joining us for another segment of the Jane Irrigation Training Series. And today I am really excited about our subject, which is design in controlled environment agriculture. This has become a really big subject over the past few years as people look for more ways and better ways to feed the world in a more in a way that's more sustainable and helps with labor and energy. And this is one of the ways that we certainly have seen a lot of gains made in the past few years. And fortunately for us today, we've got a team from Hawthorne Gardening that are joining us on this. Now, Hawthorne Gardening is a company I've been associated with now for about the last 6 years. I've been working really closely with them. And as far as a group of people, as well as into their customer base that really are interested and understanding the science behind irrigation, it's hard to find a group that does a better job than they do. They're really truly a joy to work with and really interested in making things better. And it's interesting because as I was looking on their website a few months ago, the one thing that stood out to me was Hawthorne Gardening's approach, and that is they're trying to change the world for the better. And when I matched that to the Jane mission statement of leave this world better than you found it, I understood pretty quickly why this was such a match. So first person I want to introduce from Hawthorne is Shay Donald. Shay I've been working with for a couple of years now, and again, somebody who really understands irrigation, but more importantly, everything that goes into the design of a controlled environment. And when you think about it, there's a lot of technology there. So we're very fortunate to have them speaking this week about the design. And then next week, we're bringing them back on Wednesday again to talk about how to use all the items they talk about today. So design today, how to use it next week. And with that, I want to say, Shay, welcome. And thanks for joining us today.
Awesome. Yeah, thanks a lot, Richard. Glad to be here. And thank you, everyone, for joining us. So as Richard was saying, Hawthorne Gardening Company, bit of background, we're a wholly owned subsidiary of Scott's Miracle-Gro. It's Scott's branch out into the indoor facility and indoor agriculture industry, mostly focused on cannabis now, but also on the broader sense of food production and sustainability. So I'd like to introduce Dr. Rebecca Knight. She is the newest member to the design team at Hawthorne. She is the lead there, and she has a background in both engineering and biology and understands the relationship therein, as well as Patrick Wild. He is a design engineer on the design team, focusing on HVAC, dehumidification, odor control, and basically anything to do with the environmental set points and conditions in these types of facilities. The agenda today, we're going to run through kind of Hawthorne's approach towards design in a controlled environment agriculture facility, focusing on the interplay between different subjects and how they affect each other. Rebecca is going to cover the design process itself, how we work together to put these plans together and give them to growers and business owners. And then we're going to dive a bit more into specifically lighting and its effects on irrigation, followed by irrigation and its effects on HVAC. So now I'm going to hand it over to Rebecca, who is going to speak a bit about the holistic approach.
Thank you, Shay. And hello, everybody. Good morning, good afternoon, good evening, wherever in the world you are. We're really excited to be here. And as Shay mentioned, I have a background in engineering and science. And so I can't think of a better position, better role for me to be in than to manage the design team at Hawthorne. The professional services team, they service the sales group. And the sales group, by the way, are extremely technical, but they utilize us for everything from the design, which we'll talk about today, all the way to validation, through install, through specifications, everything. It's a really wonderful process. So I'm really excited to be here today to talk to all of you. So first thing I want to do is ask all of you in the audience, it's a rhetorical question because you can't really answer back, but I want you to think about what is it that you imagine when you think about controlled environment agriculture? What do you picture when you think about indoor farming? So it might depend on where you live. If you're in Asia, especially in Japan, you know, they've termed they've used the term plant factory, and over there it tends to be really shallow racking systems, highly automated. In fact, the very first system with no human interaction from seed all the way to harvest was developed in Japan. So they have a very highly technological process for indoor farming. Or maybe if you're in North America, you might think of a cannabis grow operation. You might think of commercial farming. All of these are controlled environment agriculture, and they all have many things in common. So the first thing is, since we're not outdoors, we're not utilizing the natural sun, we're controlling everything. So on the one hand, it means you can essentially theoretically grow any crop you can imagine anywhere in the world, right? Which is exciting. And this is what I mean by having the engineering and plant biology background. I love that part about it. But on the other hand, it means you have to control all the parameters, and you have to consider how they play into each other. And so there are additional parameters than what I'm showing here. For instance, media and the grow media, as well as the nutrients that you would supply to the plant. But today we're really going to focus on the interaction, the holistic approach of the more mechanical systems. So benching, lighting, irrigation, HVAC, and airflow, all of these things have to be controlled in a controlled environment agriculture. Whether it's a medium-sized operation, as the photo in the top left, whether it's a grow tent, bottom left, a commercial greenhouse, or a unique type system with vertical tubings and maybe a greenhouse. So in order to do this, the very first step is going to be, how do you design? How do you lay out your system? Because these processes, these parameters integrate so closely, the question is, how do we do that design work? So in the next slide, I'll show you what we mean by design.
Hey, Rebecca, we had
yes.
a question here. I'm sorry to interrupt, but we did have a question.
Please.
So there's a lot that goes into this controlled environment, right? It's almost overwhelming, you know, on that last slide, everything that's there. Would you say that one is more important than the other, or if one's not working, it affects everything and you have a problem?
That's a really great question. I would say everything is important. Everything is important, and if one thing is not working, it will affect the other things. And so today we're going to focus on lighting, irrigation, and HVAC, but the way in which you space the plants, the types of benching or racking systems is also extremely important and plays a part in the other parameters, as well as the airflow. So they're all very important. They're not all equal in terms of how much they cost or how involved the design process is, but they are all very important and integrated with each other.
Yeah, okay, great, thanks. And yeah, I just want to remind all our viewers that you can use the Q&A or the chat to submit questions. Somebody already found that out, but if you want to, as we're going along, please submit your questions and I'll pass them on to the panelists. So thank you, Rebecca.
Sure. And so in terms of design, that was a really great segue, because some of the design work, such as you'll see in the left-hand side of the slide, is more about location, how things work geometrically inside the grow room. So we work with growers to, depending on the types of crops, and depending on how people will flow and harvest throughout the room, we have benching design, and we may help them with spacing and items of kind of geometric needs. But we also do design work that has to do with irrigation, and then in that case, it has to do we have to do all of the specifications and sizing for pumps and all of the equipment that would be needed for an entire facility. And by facility, I should mention that some of these commercial facilities, it's not not just a few rooms or a few dozen rooms. They could be hundreds of rooms. So greenhouses are getting very, very, very large. And so this can be an extremely big operation to design the irrigation for these types of controlled environment agriculture systems, cultivation systems. So we also have on the right-hand side and in the top and the middle, we have some, I put in some images from our light design work. Now, this is not necessarily just spatially, or it doesn't keep track of just which products we're using, but it's using photometric software. So it's using mathematical software to actually assist in figuring out which light fixtures to use, where to place them. It also considers what are the light levels at different slices within the grow room environment. And so this type of software, our design team uses this among other mathematical software to figure out how the design should be laid out, and in order to provide the customers with a package for what they need to do to have the most optimal growth. Keep in mind, it depends on the plants, the development stage. It depends on a lot of things. We have many different types of light fixtures as well as irrigation products. We have lots of Jane products. We have lots of benching and racking systems. And so the design team works with the sales team, works with the customer to figure out what would be the optimal selection of equipment and how we're going to design that out for their individual project.
Well, Dr. Knight,
any questions? Yes.
Yeah. So considering, I'm thinking about actually the building, right? It could be a greenhouse, all windows, but it could also be a block building. So my question is this: does it really matter? And are there ways to change any building to a controlled environment growing area?
The first part of the question, the space does really matter. So things like the ceiling height, that's going to affect, or even the material of the ceilings and the walls, that could affect light reflectivity. What's in the room will affect airflow. So there are the dimensions and the location really do matter. Later on, Patrick will talk more about HVAC, and HVAC is also really important when it comes to the dimensions and what's within the room. And theoretically, any space can be turned into a controlled environment agriculture. So if any of you have a basement that you're not using right now, you can turn that into controlled environment agriculture. You can start growing crops in there. There are some spaces that work better than others. For example, when you're retrofitting a building, a lot of times server buildings, because they already have sort of a subfab level, perfect for controlled environment ag. They already have the space that you would be able to put irrigation and drainage and things like that. So you could make any space a place where you're growing plants, but there are some spaces that are a little bit more ideal than others. And of course, new construction, those are great because then you get to start fresh. You get to decide exactly how you want that facility to look.
Yeah, a few years ago, I managed our website too, and I was noticing we were getting a lot of people in Detroit, Michigan, hitting our website all of a sudden, and that was new, right? You don't think of that. And then I learned about taking over a lot of the auto industry warehouse space and turning it into indoor grow facilities, and you start to think, yeah, you can do this anywhere.
That's great. Yeah, that's interesting. So in the next slide, what I want to do now is shift into one of these areas. We're going to look at lighting. So we're going to talk about these interactions. The first one is going to be lighting and irrigation. So lighting is really, really important, as you can imagine. They're all important, but lighting is maybe one of the most expensive components of the operation. It also requires energy and cost to maintain, so to keep those lights going. So lighting is really important, and it has a very big influence on the grow room environment. It interacts with the environment, so with the other parameters. So first, just want to point out that outdoors, we have the full spectrum of the sun. Granted, on a cloudy day, there'll be less intensity, but you get the full spectrum. Well, one of the neat things about indoor farming is you can supply just what the plant needs. So you're not going to give it the full electromagnetic radiation spectrum. You're not going to give it everything from radio waves to UV rays. You're just going to focus in on the rays that are important to a plant. So in this diagram, you can see I've indicated like red photons and blue photons. And that chart at the bottom kind of gives you an idea of the range of different colors that a plant would use. This is just a very general kind of range. But in the next click, what you'll see is that indoor lighting can come in a variety of forms. So each of these forms will produce different spectrums, different wavelengths. And so the one at the top you're probably very familiar with, it's fluorescent lighting. You see it in office buildings. It produces certain wavelengths of light. The one in the middle is a high intensity discharge lamp, such as high pressure sodium or metal halide. Those are very common in grow room environments, and they produce different types of light. And then recently we've seen the emergence of a lot of different LED technology. And here at Hawthorne, we have LED options that are selling like hotcakes, and we have new ones coming. So it's a really exciting field. However, the different form factors, this different technology, they all have different aspects to them. So whereas you can choose your own spectrums essentially with the LED lighting, it's based on solid state technology. So if you combine the right chips, you can get kind of the right colors that you want. Unfortunately, it's expensive. It's much more expensive than the other two options. And so you have these different aspects of technology to consider. Now, in the third point, we start looking at how lighting integrates with irrigation, and we're going to look at it in the microenvironment. So leaves photosynthesize. That's where photosynthesis happens, and it happens in an area called the photosystem. The photosystem has what they actually call it an antenna. Doesn't look like that antenna, but it's called an antenna, and it's where the different pigments of the leaf kind of come together and allow the energy from the photon to translate down into the center of the photosystem. When that energy is moved down into the center of the photosystem, that's when it's translated to chemical energy. That's the point where the plant splits water. It takes a water molecule and it converts it into hydrogen and oxygen. So it's amazing that plants can do this, because we can't figure out how to do this efficiently yet ourselves, but plants do this in photosynthesis. It's that potential energy, that split of the water molecule, that is what creates all of the downstream energy essential for the plant to create its own sugars, to grow, to maintain itself. So if there's no water, or if there's lacking water at the photosystem, then you can imagine that the plant's going to be in trouble. So a plant needs to have enough water there to be able to accept that energy. If it can't, that energy is going to go somewhere else. So you get what's called photodamage. The photodamage is when you might see a plant that hasn't been watered, but still receiving light. So that's photodamage. It's not good for the plant.
All right, so one thing that I think about here is, you know, we get about 12 hours of daylight right now, or sunlight in Southern California. So in an indoor controlled environment, can I put the lights on for 24 hours and get 2 days of growth in one day?
So that is a really great question for this last section of the slide. That's a perfect question, because it turns out that you cannot. And the reason is this. So I think if you click one more time, you'll see two terms that come up. The first term is called the daily light integral. So all plant species have what's known as a daily light integral. It's a value that indicates how much light it needs per day to thrive. Now, I will say that there are some plants and some microalgae that can develop their own circadian rhythm, but most plants need to have a dark cycle as part of their metabolic pathways and control. So plants have what's called a photoperiod. That's how long that they're exposed to light. You can decide. You can put a little bit of light on your plants and expose them longer with a longer photoperiod, or you can give them more light and expose them to a shorter photoperiod. Either way, you're giving them the same amount of light per day. The caveat is, as I mentioned earlier, you can't give plants too much light than they can handle. You'll have photodamage. That's too much energy. So there's always going to be constraints in terms of what's the maximum light levels you can give the plants. But the DLI is this indication that many things are interconnected. In this case, it's the particular crop and the developmental stage. The particular plant in developmental stage is DLI, how much photoperiod you're giving it, and what's the intensity of light. So those are interchangeable. The other term there is called VPD. That's vapor pressure deficit. What that is, and here we're talking about the interaction with lighting and irrigation in the environment. So what that term refers to is the difference in the vapor pressure of what's happening inside the leaf and what's happening outside the leaf. So it takes into account the parameters of relative humidity, the temperature of the leaf, the temperature of the ambient air. And all of these things, as you can imagine, are interacting, based on the controlled systems that we have within the cultivation room. And so, as you can see, it's very interconnected. Lighting and irrigation has many examples of interconnectivity. And to explain this a bit further, Shay is going to talk more about the environmental situation with light and irrigation.
Okay, great. Thank you, Dr. Knight. I have one more question from one of our viewers.
Sure.
And do you know of a location or a resource for determining what the cost for various crops for indoor farming is versus outdoor farming?
Oh, that's a great question. I think if you search some of the land grant universities, maybe Ag Extension, you might find some comparisons. It really depends on your like electricity cost. Of course, you're going to need to have certain, electricity if you're going to be running lighting, which in a greenhouse, depending on your location, you might be able to get away with it with not having supplemental lighting, but oftentimes growers do need supplemental lighting. And so it's the land cost, it's the electricity cost. There's a lot that's involved in that. If you, I really love the basement idea. If you have a basement and you can afford the initial capital cost for LEDs, then it could be quite affordable. But it also depends on the crops. Some crops require more light. They have a higher DLI than other crops. Lettuces, for example, are some of the cheapest crops to grow. They grow fast. Microgreens, very, very cheap. But as you get more complicated, as you get into more light-intensive crops like tomato, cucumbers, peppers, then it's going to be more expensive. So you may run the calculation and determine that your each tomato costs so many dollars. But then again, you grew it. It's your tomato. You know where it comes from. You didn't have to go to the grocery store to get it. So it's all kind of it's dependent on many different things.
Yeah, no, that's very helpful. And right, a lot of the answers that we have on here start with the words "it depends," right? And this is certainly one of those situations. So, okay, well, I think we're moving on to Shay now.
Great. All right. Thanks, Rebecca. So one of the main tying factors between lighting and irrigation is something a lot of irrigation folks out there are probably familiar with, and that's the evapotranspiration rate. So when you're dealing with something out in the field, you don't have the luxury of getting to choose your humidity and temperature range. And so you kind of have to adjust things on the fly and figure out how to water based on a daily interval that might be changing and a whole bunch of different factors. Now, when you're indoors, obviously you have complete control over those things. And on this graph here, you can see on the right, we've got a HID style light. And then on the left, we've got an LED there. And these little balls here are representing transpiration. So one of the nice things about HID lighting is it produces a lot of radiant heat. With that radiant heat, the plant is going to be transpiring a lot more just because of that BPV change that Rebecca was speaking about earlier. So when you have an LED, it doesn't have as much radiant heat. There's a lot less transpiration. And so you're going to need to adapt to that. And this is something a lot of growers had to learn the hard way. When LED started becoming popular a few years ago, a lot of growers had a lot of set points like their humidity, their temperature, their irrigation frequency and duration. And they kept all those things the same and then dropped in some LED lights. And all of a sudden their crops were behaving really funny. You know, they were transpiring less, so there was less water being taken up and less nutrients therefore being taken up. And on top of that, they were irrigating just the same. So then the plants were kind of sitting in there with wet feet, so to speak. And just not able to grow as well. And so growers realized they needed to change all of these set points that they'd become accustomed to in order to adapt to growing with LED lights. And there are a ton of benefits that come with that, but it just kind of highlights that all these things are interconnected. And unfortunately, sometimes you have to learn that the hard way. So with that change, it also ties into the HVAC. Obviously, if you have something like HID and you've got a lot more water being deposited into the air, it's not something that you really need to worry about in traditional field agriculture, because I don't think that there's many crops besides maybe giant forests that could alter the humidity of their environment. So with that, you need to get rid of it somehow. And the way that we do that is in greenhouses, usually with big vents, but with an indoor facility, also exhaust fans, but in an indoor facility, it's an HVAC system. So any questions before we move to the next slide?
Yeah, just one here. So are they actually, are growers actually measuring ET per building? And if they are, how do they do that?
So they do it a lot differently. It's a lot different of an approach compared to something you'd see in field agriculture, because obviously with the root ball being so small and the volume of the media being so small, you kind of have to approach it in a way that's not the same as a field agriculture, in inch acres and that sort of a thing. It's more about achieving a certain amount of drainage water coming out of the bottom of the crop. They'll have a target for the day that you want to reach. And that just ensures that you're getting all of that nutrient solution nice and evenly distributed within the pot. And you have to do that every day. So, some media types, like rock wool, for example, you have to irrigate as many as 20 times a day plus at the peak of production, just because that's the best way to keep them saturated but not kind of soggy and drowning, so to speak. Does that answer the question there?
Yeah, great. Thank you.
Great. So this next slide here is just kind of showing that you need to balance the evapotranspiration coming off of the crop with what your HVAC is capable of. And you need to also not really oversize it. Patrick will get into this more, but because plants don't like to have sudden spikes and changes in their humidity or temperature or really any sort of set points. So if you have a really massive HVAC system, you get your humidity reaches, let's say 70%, and then all of a sudden it shoots down to 60%, and then it bounces back up, and it's doing that all day. Then you might have increased pest pressures, disease pressures rather, like powdery mildew, botrytis even, all these things that can kind of sneak up on you if you're not keeping everything balanced. And now, if there's no more questions on this specifically, I'm now going to hand it off to Patrick, who is going to take more of a deep dive into HVAC systems and how we integrate all these things together.
Yeah, thanks, Shay. And I do have one more question before we go to Patrick. Do growers reuse the condensate from the HVAC at all?
Yes, yeah, there are quite a few growers who do that. There are sometimes concerns that heavy metals can be accompanying that condensate water when you collect it. So there are systems available that just filter that out. They're kind of similar to an RO system, reverse osmosis. But yeah, you can actually get very high efficiencies by capturing that condensate water and putting it back into your water tanks.
Yeah. Okay, great. Thank you, Shay. All right, Patrick, good afternoon. How are you?
I'm doing well. All right, so as Shay started to mention there, HVAC is heating, ventilation, and air conditioning, and it's a very important component in controlled environment agriculture because all the water being introduced in, we now have to manually, mechanically remove it and bring that water out, or else it's still going to be in the space. So also answering that question earlier about counting ET rates and whatnot, you have a little bit of a cheat there where you know how much is going in and how much is going out. So it can simplify the process for finding the ET rate. But in the industry traditionally, growers would water by hand. We are starting to move away from that towards precision applications, and that makes it a lot easier on the mechanical side of things. You can imagine that if you have one very large watering event, all the mechanical equipment then has to pull that moisture out in a very small period of time. You might remain above the threshold for disease pressure for a longer period of time in that manner, versus if you water frequently with less water each time, the mechanical system can quickly get your room under control, and it will minimize your disease pressures. So on the next slide, we have an example situation with some lights and some HVAC to see the balance. So this example is during the day period. On the left, you can see that we've chosen a Gavita LED. So the orange arrow pointing upwards is demonstrating that the Gavita light, when it's running, produces a lot of heat. So in this room that we have here, this balance, all the heat going up, we're driving that up with the lights. Moisture with the plants, the irrigation, the plants, they'll put off moisture. That'll increase the moisture in the space. And then you can follow those arrows to the right side and see the mechanical equipment that is responsible for removing those conditions. So the dehumidifier, which is on the top, when it runs, it will produce a little bit of heat into the space. It is an electrical system, but it will dramatically reduce the amount of moisture in the space. And then if you have an HVAC system as well, that is the only component that will provide the cooling. So that's why the orange heat arrow is going downwards. And then you also get a little bit of free, I guess you could say, or accidental dehumidification as well. So we have that very small blue arrow pointing down there as well. And what's important to note here is that we do have this arrow between the dehumidifier and the HVAC system. The dehumidifiers traditionally are in the space. So when they run, the heat that they produce then has to be included in our calculation for removal. So you can see that trying to create a balance where you have different mechanical objects pulling different directions, sometimes in opposite directions from each other, getting your balance right is very important, and getting it right at the beginning is very important. So now if we go to the next slide, this is the day cycle, or the night cycle, pardon me. So the top left, the light is now off. We no longer have the orange arrow showing our heat is improving, or increasing, sorry. However, we do still have the arrow upwards for moisture. It's a little bit smaller than it was before, but it takes a while for the plant system to wind down. There will still be moisture put into the room. There will still be pipes, that will be producing moisture into the room. So during the night cycle, the dehumidifiers will be the main mechanical system running. So as you can see, the HVAC arrows have become very small. We don't have all that light and all that heat being produced, so the cooling doesn't need to run as frequently, which means that we don't get as much moisture removed by the HVAC system, which means that the dehumidifiers then have to take over the majority of the work. So you can see that the blue arrow has increased in size and the orange arrow has increased in size. So during the night period, generally just the HVAC system will be running in order to pull out the heat that comes from the dehumidifier system. Yeah, I think that's a good transition to the next slide if we don't have any questions.
So it's interesting, right? Because on one hand, controlling your environment seems like it makes it easier, but there's a lot of variables now that you have to figure out that you don't have to if you're outside, right? Because you're just you have to just take what you get there.
Certainly.
Do people adjust to this pretty easily? Are there software that helps them figure this out? What do they do about that?
Yeah, so it can be very complicated depending on the system, and that's part of the difficulties. The room environment will dramatically impact what sort of systems work for you. And so the same exact protocol in one room might not work in another. I will say that when it works, it is the best ever because it works. It just works. But getting there can take a little bit of setup. But that is the value in a group like technical services and why we have the design team. A lot of money and a lot of investment into these processes and these products. So we want to make sure that everything is set up correctly to start. And we will frequently come into contact with people who have taken expertise from outside of controlled environment agriculture. HVAC for people is very different than HVAC for plants. During the nighttime, you don't need to run your HVAC as cold. For plants, you need some mechanical system running. So yeah, that's one of the benefits that we bring to the industry there.
Yeah, and maybe because it's just super hot in Southern California right now, I'm always thinking about air conditioning and cooling right now, but there are times of the year where we're actually warming the room. Is that correct?
Yeah, and so that certainly depends on the scenario. If you have a greenhouse, that can be a common thing. Depending on what your system is for bringing in new air, if you're in a cold climate, you may need to precondition that air before it reaches the plants. But yeah, so generally it is cooling, but certainly there are applications when heating is required.
Yeah. Okay, great. And then we have places where we can look to see what's the optimal humidity for each individual plant.
Certainly. So with that, at least in the, it depends on your crop. And within the cannabis industry, it very much depends on the secret recipes or the master recipes that people have. There's a lot of different plants, different strains, different conditions, a lot of different moving parts. And so depending on, like what your lights are, what your irrigation style is, what you're irrigating into, that can also change your set points as well. So I hate to say it's complicated, but it is complicated.
It is, and proprietary too, right? I mean, this is why I get this product. So yeah, okay. Thanks, Patrick.
Of course. Yeah, so, and with this right here also, I was misleading everyone a little bit with my label of HVAC. Technically, the Quest unit that you can see on the right of the screen is actually a very, very, very large dehumidifier that is designed for these loads. A traditional human HVAC system is designed to cool and remove moisture that is produced by humans in the building. The plants produce a lot more moisture than humans do. So having this very large system that can run during the day and during the night is critical because we need dehumidification during night and day. We don't always need the cooling. And so then there is also a mechanical component of this system that allows you to decide what you do with the heat. So if you want to reject all of your heat to the outdoors, you're not doing any heating. If you would like to reject some of your heat to the inside, you're doing some reheat. You could put it all if you need to increase the heat. So that flexibility, particularly with the plant environment and within one mechanical piece of mechanical equipment rather than a bunch in a space, very valuable. But the keynotes to take away from here is that watering does dramatically affect HVAC. As we talked about earlier, low and slow, spread out the watering load across the day. It makes life a lot easier on the mechanical equipment and lower the potential for disease pressure in your space. And then finally, also, as you can start to see, there's a lot of complexity. So both the dehumidifiers and HVAC remove the moisture. HVAC's the only thing that provides cooling. So you really want to have a balance in your space, and you want to make sure that it's dialed in well. And then finally, the last point, quality equipment is key. Inefficient systems, you're now paying to reject that heat. So if you have an inefficient compressor or an inefficient dehumidifier, your upfront cost might be dramatically reduced, but you're going to pay for it in the long run. So we really recommend quality systems. And in particularly, too, you get more features with quality systems. You can maintain a set point rather than bouncing around the set point because of the extra heat being added. So, yeah, I think that's a good place to stop for HVAC as an introduction.
Yeah. So, all right. Well, I do have one more question, right? So with HVAC, you can do set points for temperature and humidity sensors, right? And turn things off and on based on that. But what do you do for irrigation? Is there a set point for that? How do you figure out how much water to give every day?
Certainly. Yeah. So this ties back into more what, Shay, was that you chiming in there?
Oh, no, go ahead.
Oh, well, I was going to pitch it to you a little bit, but yeah, no, certainly. So different media will require different watering densities and rates. If you want specifics, that is something that Shay is much more experienced with than I am. But those different watering rates will affect the HVAC system.
Yeah. Okay, great. Thank you, Patrick.
And maybe just delving into that a bit deeper, now there's a lot more sensing technology coming out, as well as kind of a more traditional approach would be that monitoring the amount of leachate coming out the bottom of the pot, essentially, and having a target throughout the day. But when it comes to irrigating different media types, it's really about keeping available water in the root zone so that the plant can readily keep it or take it up, but also while preventing any waterlogging, because obviously in a pot and depending on the media type, you can reduce the amount of oxygen in the root zone, which can lead to pathogenic organisms spreading and growing. So yeah, it's there are a lot of different approaches to that, and I think it's very dependent on the media type, the pot size, and then the VPD and all these other set points there. But essentially, I mean, if you're going to grow things really dry, you're going to have to water a lot more to keep up with that. Yeah.
Yeah. Okay, great. We had another question too, and this is one I'm also curious about, right? We see lots of fans inside growing facilities, right? They almost look like oscillating fans. Why are they there? What do they do?
Yeah, certainly. So I can jump in on this one. Fans are very important for a couple of reasons. So first off, we want to make sure that the dehumidification and the cooling that we have, spent a lot of money on is well mixed within the environment. If you don't, then you will start to see microclimates or gradations as you move across your space. So that's the first reason. Second reason for lots of airflow is it's related with evapotranspiration rate and with VPD. If you increase the airflow across the surface of the leaf, you decrease what the relative humidity is at that point, and that will increase the uptake of water and nutrients and increase your evapotranspiration rate. So that's the second reason. More nutrients, more growth, more everything. We like that, more energy in the plant. And then finally is for disease pressures. So minimizing disease pressures is one of the main purposes of fans. So yes, no, you will walk into a controlled environment agriculture space, and unlike a greenhouse where you might have some horizontal airflow fans above up on the top, you will frequently see fans covering large portions of the wall, large portions of all the walls. So
yeah. Okay, great. And I've got another question. We've got a lot of great questions today. This viewer is asking about mechanical harvesting. I'm not sure who would get this question, but do you see any of this happening right now in controlled environment agriculture?
Yeah.
I can take this one. And Shay, feel free to follow up.
Sure.
I've seen, as I mentioned early in the discussion, I've seen certain areas of the world. For example, Japan has really taken on like robotics and automation, with mechanical systems doing everything from picking up the seed and placing it into the grow media to boxing up the final product. So there's equipment out there. I think that in some cases it might be it's nice to have, but maybe not needed. Maybe it drives the cost of the product up too high, so it may not be economical for all cases. But it is kind of fun as to see if it works, and I know it's been developed for different types of products. So if you go to a horticulture conference, and there are many of them, you will see all types of inventions and picking equipment. So I know it's been developed, but whether or not it's being used in practice, I don't know to what extent, especially in the US.
Yeah. Great, thank you. That's very interesting. It'll be interesting to see what happens in the future with this as well.
It will.
Cool. Should we move to the next slide? I think it's a summary. So, so yeah, just to summarize here, several systems interact, and these are all very they interact very closely, and there are a lot that we didn't cover, like Rebecca mentioned. These things include nutrients, growing media, we've got the environment, lighting, and everything like that. And we do have a team of people on the technical services department that they are often specialized into their own kind of segment, but then we try and be generalists as well. So all those things are taken into account during the design phase, but then also, as we'll speak about next week, on the actual management and use of these systems. So to reiterate, the irrigation and lighting, interplaying at both the micro and macro level, as well as irrigation, dehum, and HVAC. All those things need to be carefully balanced in order to have a efficient and high yielding facility. So yeah, I think that about wraps it up there. And now I guess we'll open it up to questions.
Yeah, so you guys did a fantastic job today. You know, we still see a few more questions trickling in on how much to water, and I know we'll be covering that a little bit more next week. I did want to say thank you, Patrick, Shay, and Rebecca. You guys did a fabulous job today. This was really interesting and a lot of great interaction from our audience. I know all of them are going to be interested to see you guys come back next week and talk about how to actually put the design into use. That's going to be very helpful. I know I can't wait, and I always find this super interesting, and you're getting a lot of nice comments right now coming in the chat. So thank you guys so much for doing this. Really appreciate it. And again, we'll be back here next Wednesday to talk about more about controlled environment agriculture with our panel. And remember, we do have these recordings on our website, as well as we're on Apple, Google, Spotify, and iHeartRadio podcasts now. So you can search any of those for Jane Irrigation or irrigation in general, and you'll find almost 50 of our presentations now. So again, you guys, thank you so much. You guys were fantastic. I want to say to our audience, thank you for taking time, your valuable lunch hour to spend with us to learn more about irrigation and technology today in growing. So thanks very much, everybody, and we'll see you all next Wednesday. Thank you very much.
Great.